Okay, so let's start the week 4 session for the Introduction to Wheeled Mobile Robots NPTEL PMRF TA session. And in this session, we will be discussing about sensors and solve the assignment related to week 4. Uh, my name is Suraj Borate. I am a PhD scholar from IIT Gandhinagar, and I am taking this TA session as part of my PMRF duties. And so the idea behind this session is to enable the students of NPTEL to ask doubts and help them with the assignment questions. So we will not solve the current assignment, but a previous year assignment, which are usually very similar to the current year assignment. So if you are able to solve the previous year assignment, you will definitely do good at the current year. So let me just check the recording. Okay, so it's recording. Uh, okay, all right. So let's start with the first question. So which of the below system is constrained to perform tasks having least complexity given the robotic systems have least sensing and perception capabilities? So a remotely operated mobile robot, a teleoperated surgical robot, an autonomous underwater robot, or hybrid robots. So this is a very what do we say, a fuzzy question. Let's try to analyze each option. So remotely operated mobile robot. Uh, so it depends. It depends on what kind of environment it is operating in, right? So remotely operated mobile robot can be any robot, but I assume that it is a ground robot. Let's assume it is a ground robot, and uh, so it has to perform tasks having least complexity. So a remotely operated mobile robot, complexity depends on what task it is being doing. So I think it's not a very clear option, but I think the question is more about having least sensing and perception capabilities. So if you mount a remotely operated robot with camera, it can give you very good sensing if there is a daylight or something like that, or enough illumination is there. So sensing is not a very big challenge for ground robots, right? Teleoperated surgical robots. So again, these are very costly robots with mounted with very good encoders at each joint, and I think they are also equipped with good sensors. Sensing is not a challenge. Hybrid robots. Okay, hybrid robots are the robots which are multimodal kind. They can travel in multiple. So someone is joining, so let's add the participant. Okay, yes. So we were discussing the first question, and it basically asks which type of robot has the least sensing and perception capabilities, right? So this is mostly based on what environment the robot is operating in, right? And also what kind of uh, task the robot is performing. So for a surgical robot, you need a very precision task, and so you need a very high level encoders and force sensors maybe to be mounted at the joints and on the end effector, let's say. So teleoperated surgical robot need to have good sensing capabilities. Remotely operated mobile robot can have good sensing capabilities. I think on ground you have seen a self-driving car also can be mounted with lidars, radars, sonars, IMUs, and they perform very well on ground. Hybrid robots are like multimodal robots, and multimodal robots can operate in multiple environments, so they can also have good sensors. But an autonomous underwater robot, if you see, it is performing underwater where visibility is very low. Also, you cannot have lidar based sensors, so you can only operate on sonar, right? Ultrasonic sonar, and these have a lot of variance. So the perception and sensing capabilities and even communication capabilities underwater are a challenge. So the answer here is C. Apart from that, even there are other challenges for underwater robots like structural. So if you go below the sea level, the pressure starts increasing, and at a point, if you have any openings like uh, like a bearing somewhere where a shaft is coming out, water can just go through that, and even the structure can collapse under pressure. So there have to be special motors that can, so every component, which is not shielded by the structure, that has to be rated for that particular pressure. uh, so yeah, underwater robotics in general is very very challenging, um, especially at greater depths. Okay, so let's move on to the next question. The process by which the people, so if the screen is not visible or my voice is not audible, please turn on your mic and tell me. Okay. Uh, so the process by which people translate sensory impressions into coherent and unified view of the world around them. Okay. So one is taking the sensory input or the energy in, right? And then the other thing is to make sense of it, right? Make sense of it in the means, in a way, is like understanding it. Okay, so one is like clicking a picture, but then uh, from the picture understanding, okay, this is high traffic or the road is free for to move. Okay, so that is understanding. Okay, uh, that is like creating a coherent and unified view of the world around. So this is called perception, right? uh, Sensing and perception. So this is also a theory question. So today's assignment is mostly theory, so we won't be requiring that much time. We will be finishing it quick, and we'll have a lot of time for your questions, if you have any. Okay, so select sensor system which cannot be classified as both exteroceptive and proprioceptive. So what is exteroceptive sensors? The sensors which measure the environment, right? And proprioceptive are the ones which measure themselves, so measure data about the robot. Okay, and exteroceptive are ones which measure data external to the robot. Okay, and active and passive means what? So active means uh, you send energy, uh, and you receive it back, and then create a measurement from that. And passive is like you just wait for the energy, let's say a mic, right? You just wait for the sound to come and then you measure it. So that is passive. So the question asks for exteroceptive and active sensor systems. So if you see contact switches, so what is contact switch? So contact switch measures external contact, right? So let's say you put some switches on the bumper of the your vehicle. So when when say let the robot collides somewhere, then it will like get pressed. Okay, and you detect the collision. So that is one kind of very, if you are creating a very uh, low cost and basic algorithms, then you can use such, contact switches. So low cost robots with basic algorithms like bug algorithms and all. So you will be learning those hopefully in coming lectures, or you can just look at motion planning algorithms or something like that. So there is this book by Hovi Choseth on motion planning. So in that it's given that bug algorithms are the most like basic kind of path planning algorithms. So this only come to know. So here the robot is like a bug, which has very limited visibility. So if you want to implement the bug algorithm in reality, it means that you have to use something like contact switches. So when it goes and hits the obstacle, only then it will come to know that there is an obstacle. So it doesn't have any visibility. Okay. So that is an exteroceptive sensor. Is it an active sensor? No. it is not an active sensor. So this answer cannot be there. You need both exteroceptive and active. Okay, why it is not active? Because unless and it is until an external energy presses it, you cannot know. It is not sending an energy, right? Anything, any rays or something. Okay, non-contact proximity sensors. Okay, so what is a non-contact proximity sensor? So proximity sensor basically is like something that measures uh, your environment through sending, let's say, ultrasonic wave and receiving it if it is ultrasonic sensor, or IR sensor also, like it will send there is a transmitter and a receiver. Okay, so if you look at IR sensor, they look something like this. uh, so this is like ultrasonic sensor, and IR sensor, if you look, there are two small bulbs very side to side. Okay, so there is one transmitter which sends signal, and then another is receives after reflection. Okay, so these are both active and exteroceptive. So when the question says cannot, and so this cannot be the answer. Okay, so optimal barrier. What is optimal barrier? Okay, I have no idea what is optimal barrier. Gyroscope. So gyroscope is uh, a sensor that measures the angular rates of the robot. Okay, so this can be you know a mechanical gyroscope, or it can be something like system on chip, right? Or what we say MEMS sensor. Okay, like something like IMU 6050 has this gyroscope and accelerometer, right? So it's like a MEMS thing, like it's small circuit, very small circuit, PCB, not PCB exactly, but like SMD component will come, which will be mounted on a very small circuit. Okay, like something like 2 centimeter cross 1 centimeter. Okay, so those are actually available, and mostly we don't use mechanical gyroscopes for robotic applications. Okay, so this sensor is proprioceptive, so and it is also so it is not exteroceptive, and it is active or passive. So it doesn't send any energy out. It just whatever motion happens and it detects. So it is passive. So this is the right answer. Okay, A and D is the right answer. And now if you see Doppler radar, again this is active. Radar will, uh, it will what do we say, send rays and receive back, right? So this is also active, so this cannot be the answer. Optical encoder is passive. Why is it passive? No, no, it is active. Optical encoder is active because there is a disc in between, and there is one side there will be a LED which will emit light, and there are slots in this disc, and the light will pass through the slot, and on another side you will have the light dependent resistor or something that can detect the light. Okay, now the thing is it will count the number of slot when this disc rotates. Okay, so slots are something like this, and by that you can measure how much angle the encoder has turned. Okay, so here you can see some energy is sent and received. Again, it is received inside the sensor itself, so that was why I was little bit confused of active and passive. But yeah, we can call it active because energy was sent and received. Excuse me. Sorry for that. Yeah, so the answer is it is active, and it is also not exteroceptive, because it gives again the information about the how much the wheel has moved or the joint has moved, right? So it is proprioceptive, so it means that yeah, this is also answer because it is said that it cannot be classified, right? So the answer here, let me write down, is A, D, and F. A, D, and F. Ah, sorry. Select the wrong statement. The accelerometer are used in a robotic system for the measurement of. Okay. So displacement if the acceleration is known, linear acceleration if the displacement is known. Okay. Jerks on the system, force acting on the system in the mass is known. So basically, yeah. So I think the A is the right answer because once you know the acceleration, you can integrate to find the displacement. Okay. Uh, it doesn't make sense to find the linear acceleration if displacement is known. Usually, you know the linear displacement, you know the position of the robot, and you can have a position control algorithm going on. Rarely you need to find reverse. Mostly this is what is done. Jerks on the system. Maybe maybe in some particular application, jerks on the system, you can differentiate the acceleration data and do something about it or something like that. But these are very specific applications. Force acting on the system if mass is known, possible, possible, can be done, but this is the most common thing that is done in robotics community. So which of the following sensors are not incorporated in inertial measurement unit for estimating the 6 degree of freedom orientation, position and orientation? Okay, so so two words here, 6 degree of freedom. Okay, so this is a rigid body, okay, in space that can have like three x, y, and z translations, and to define a rotation you need, or orientation you need, at least three parameters. Uh, let's say it can be Euler angles, or it can be just, you can imagine as a rotation about these three axes. So by two angles you can define an axis, a particular direction of sphere, let's say uh, along the longitude and along the latitude. Okay, you define a direction and then you spin around this direction, so there are total three angles. Okay, uh, what do we need? We need the position and orientation of the system. Okay, and how are we going to measure it? Using IMU. So this IMU usually has accelerometer and gyroscope. Some will also have magnetometer. Okay, this increases the accuracy of orientation measurement. Okay, uh, but it doesn't have encoder and vision sensor, so it's pretty easy. Okay, what is the minimum number of satellites required in GPS? Okay, so the GPS that we are currently using has 24 satellites. So that is one of the facts that we should know. Uh, and how what but they have asked is the minimum number of satellites that is required. So minimum number uh, is 4. Okay, 4. And why 4? Because see, let's say this is a satellite and this is Earth. Okay, so this satellite will have some range, and so this is a circle on Earth. If you see from this view on Earth, you will have a certain region. Now if you want more accurate localization, then if you have one more satellite. Okay, so earlier your area was this, then now there will be some intersection. Okay, there will be some intersection here, and you will get, let's say, this area. Okay, right, and a third satellite, what it will do, it will minimize it further. Okay, minimize it further. So more the satellites, better accuracy, but let's say it minimizes. Okay. Uh, Another way you can look at it is this way. If there are three points in space, then you can have kind of triangulation kind of system. Okay, but then there is a fourth satellite that is used, uh, that is to correct the timing. Okay, so this course doesn't require us to go into lot of details of it. Even sir in his lecture hasn't gone into. But the thing is, the timing correction, you can think of it as less. Satellites are moving at a very high speed. Okay, and the 24-hour uh, day that we follow, that is also not exact. Okay, it's not 24-hour only, it can vary. And so there are some corrections to be made. Also, the relative positions and speeds of the satellites also have to be taken into account in that. And so that correction, for that all that correction, a fourth satellite is required. Okay, what I have given is very vague information, but uh, if you want to know more in detail and all, then you let me know. We can cover it next time, or you can do some self study. Yeah, but for the course purposes, this fact, like, you just need to know this fact. Okay. A floor cleaning robot is placed at position A and it detects an obstacle at position B with the help of an ultrasonic sensor. The sensor values are as follows: the speed of wave propagation. So this is something what we used to do in school, right? So let's say the C is speed of sound is 340 meters per second and the time of light is 0.04 seconds. So distance between will be what? So speed is equal to distance upon time. But the time required to cover this distance is nothing but t by 2. Okay, so the distance is 340 divided by 0.04 by 2. Right, so this is 340 divided by 2 into 100. So no, 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 yeah, that is a mistake. This is C. So what do we need? We need D, right? So we have to multiply into, yeah. So this is 340 into 0.04. Okay, it's very easy problem. 0.02. So if you multiply this, will come on to 6.8 seconds. 6.8, sorry, meters. Yeah, just plug in the value distance upon time. Okay, so very simple problem. Okay, select the principle which are used in proximity sensor. Okay, so inductance based are there, capacitive based are there, light density modulation. Okay, ultrasonic wave. Yeah. So yeah, resistivity. This I haven't seen. Okay, so for resistivity change, I think you have to, so you can have some, creative ideas for some specific type. Let's say if there is an hot object, okay, and you have to detect that hot object, then maybe, you can have a resistive screen, and when the hot object comes close, okay, so Sanjay has joined, but I think we have already reached the ninth question. So, uh, okay, so let's have two questions for Sanjay. So okay, so let's say a hot object is there. So that we were discussing this question, select principle which are used in a proximity sensor. So we know inductive based and capacitive based touch screens are there, and you can even have proximity sensor like that, where you can bring some metal close by and you can have the change in inductance or something like that. Capacitive based is also there, uh, but uh, so Ohm's principle of resistivity based sensors, proximity sensor doesn't make that much sense. But I am saying that just if you have some creative thought, that can also be possible. But while giving you assignment, don't be too creative. Okay. So just to be for fun, I am saying that let's say there is a hot object and it comes close to some resistor based screen. Okay, then you can detect the resistance might little bit change and you can detect the uh, temperature. Why the resistance will change? Because the resistance depends on temperature, right? So we know that R depends on rho A delta T or something like that. We had studied in 11th, 12th. So this is resistivity, area, and the change in temperature. So so don't be so creative. Stick to what has been taught in course while answering the question. Okay, you can always cook up some sensing mechanism, but that is not is what being asked, right? So let's move on to the last question. Okay, so according to error propagation law, the output covariance is given by the relation. So covariance matrix representing the propagated uncertainties and Cy. So propagated means y is equal to f of x, right? Y is equal to f of x. So x is the measurement and y is a function of the measurement. And what we want to understand is what is the characteristic of y, right? So we know that x has some mu and sigma. Okay, let's say it is one dimensional. Okay, so uh, x will have some mu and sigma, and y will also have some mu y and sigma y. So mu y is easier to find, but sigma y, how will are we going to find? Uh, so that is the question, and in this case, x is not one dimensional. X is a vector, which can have, let's say, m dimensions. Okay, so in that case, how will we find the variance? And first of all, is there a variance for a multidimensional case? So for multidimensional case, variance is replaced by covariance. Okay, so let's say sigma y, uh, like, there will be some covariance matrix over here. Okay, and you have to have so if there are uh, so f of x is Jacobian, right? So Jacobian is Jacobian matrix. So uh, if this is m dimensional vector, and then this will be how many? So let's say y is n dimensional, n cross 1, and x is m cross 1. Okay, so this will be dou f1 by dou x1, right? Dou f2 by dou x2, and dou fn by dou xm. So sorry, this is f1, this will be f1, dot 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 dou fm, sorry, n by dou x1, and dot 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 dou fn by dou xm. Okay, so this is the Jacobian matrix which we had seen in the context of uh, kinematics, right? But you can see that that thing is appearing here again with a different application. Okay, so this is m. If you don't understand, please ask. Okay, so yeah, so this is the matrix. This is what n cross m. Okay, and then you have uh, this is the formula. Okay, this was given by sir in the lecture. So this is n cross m, and here you will have its transpose, so this will be m cross n, and so your covariance matrix for x will be m cross m, and it will be like sigma x1, sigma x2, dot dot sigma xm, and then the other non-diagonal terms will be the covariance of the x1 x3 or x1 x4 like that. So what is covariance? First of all, what is variance, right? So variance is the spread of the values around the mean, right? So how much the values differ from the mean, that is what variance say. Okay, now when we say about covariance, how do we try to understand covariance? Can anyone tell? So this is like not related to the course, but okay, we can have some discussion. So we have already solved the 10 questions. So can anyone tell me what is covariance? What do you understand by covariance, Sanjay? What is covariance? Hello, are you there? No idea. Okay, okay. Okay, so the thing is variance, have you heard about variance? Right, you have seen this kind of figure, Gaussian curve or bell curve. So this is the mean, okay, this is the mean, and this is the variance. Okay, so the basically I will just give you the intuition. Okay, so the thing is, uh, let's understand the one dimensional case. Okay, so if you have a sensor, let's say ultrasonic sensor, and you have kept the object over here. There is a ball and you are measuring it. You measure one time, you note the value. Okay, and that value was, let's say, 10 meter. Okay, now you note the value was 1.1. Okay, next time you note it was 9.8. Okay, then you note again it was 9.8, again you measured it was again 10. Okay, so what you do is you keep on measuring and find and plot the how many times that value is appearing. Okay, so this is like number of times you get that particular value, and this is the sensor value. Okay, so you see that, or you can say probability of that value occurring. If it is continuous, then we will say probability of that value occurring, and you will get some curve. Okay, and let's say 10 meter is like maximum number of times the sensor is giving 10 meters. So we will say that this is like this becomes the mean, or it eventually, like, if this is going to be maximum, so mean will be nearby here, nearby 10. And uh, what will be the variance will show that how much how much spread is there. So let's say two graphs are there. This is one graph. Okay, so here one sensor is there, and here another sensor is there. Okay, so in this graph you see that the sensor gives like very accurate reading, not accurate but very precise reading. You are getting all most of the values near. Okay, whereas this sensor is giving like a longer range. Okay, so here the variance is high. So that is the idea of variance and mean. And when you do for multi-dimensional, let's say now you don't have to measure only one value, you have to measure x1 comma x2. You have to measure two values by the same sensor. Okay, or by, let's say, different sensor, but by let's say that process gives you two value. Okay, without going too much detail, but let's say you are getting two values. Now what you will do? Okay, now you cannot have two things be plotted over here, na? Okay, so now you will say that, okay, you will have x1 x2. Okay, and then you will have one graph like that upward. Okay, and now you will have a two-dimensional, let's say, peak kind of thing. Okay, but if you see only this, it will be kind of ellipse. Okay, So now what you say? You say error variance in x direction. What is the variance in x direction, and what is variance in x2 direction, x1 direction, x2 direction, and what is the variance in x1 and x2, like in a direction where both, both are correlated or something like that. Okay, so only when you are considering x, and what is a variance when you are considering both x1 and x2. Okay, so I may not have explained this very clearly, so you can look it up. But yeah, the course in last lecture, sir has given only this formula. Okay, I think for the covariance. Okay, so it is like saying uh, how much x1 and x2 are together when they are changed. Okay, not changed, but how to say, how x1 and x2 depend, how y depends on both x1 and x2. Okay, so it's like saying that if x1 value is increased, is x2 value decreasing or increasing? Okay, if x1 is increased, x2 is also increasing, then we will say that the this component sigma x1 x2 is positive. Okay, if x1 is increasing and the trend is that x2 is decreasing, then we will say it's negative. So it's kind of a trend. Okay, and so that is what you can also see in that covariance matrix, but you can read it up on Wikipedia. Okay, but for as far as the course is concerned, uh, for week 4 this much definition is enough. Okay, for localization and all, this theory will be useful, so read up a little bit of probability and what we say, the Gaussian stuff. Okay, mean variance stuff. So all questions are covered. If you want me to go to any specific question, please let me know again, or anything from the course. So this was pure theory question, so we covered it very fast today. Any questions? Any doubts from previous lectures? So I will stay here for 15 more minutes. You can ask any doubt if you want. Or do you want me to end the session? So let's do something interesting. Let's see what Wikipedia talks about covariance. Okay. Yeah. So like I said, so there will be x1, x2, and then there will be some trend. Okay, some trend, and the peak of this denotes, z-axis denotes the probability or the frequency, right? So when there are two variables, you can have, yeah, you can see here. So because x and y components co-vary, okay, when you say co-vary, it means that there is a trend between these two. So they vary with a trend, or they are function of each other, the variances x and y do not fully describe the distribution. So only variance in y or variance in x will not be able to describe the distribution. So that is the intuition. Okay, so you can further study this. Is there any question, Sanjay? And there's one more participant whose name is Cute Baby Love. So if you have any question, you haven't asked anything. If you want me to repeat any questions or take up some questions, please tell.
Hi, sir.
Yes.
I have a doubt not related to course, but how would be the final exams? Will it be
Yeah.
online?
So final exam will be a written exam, no? So you
Uh,
will be going to a center and you will be writing a theory proper question answers.
uh,
I don't think the final exam will be just objective. I think there will be questions in that. I'm not
is
sure
it?
whether you have to code or not in the exam. That I'm not sure. But
Uh,
usually, I think so that's not something which I am concerned with. So but I think some of my friends had taken it before. So it is mostly theory paper, as far as I know. This time, if they come up with something, then I don't know.
okay.
Hmm.
I
So
am little bit weak in MATLAB. I started learning it.
yeah, so
Few,
that is the objective, no? So if you are weak in MATLAB, so you have to do MATLAB, and
yes, I
this
am.
course allows you to give a reason to do a MATLAB. Usually programming languages you cannot just learn directly without having any assignment. So you learn by doing. So at least they are giving you some objective to simulate something, and also while simulating you will get errors, and from errors you learn. More errors you do, more you learn. So
Okay, sir.
that is how. So you are understanding all the questions that I told, na? Like, uh,
Yes, I am able to do the assignments.
uh-huh. Yeah, assignments are easy. If you follow the lecture, assignment are easy. Directly from lectures they are asking. So if you don't mind, can you tell something about yourself, like what year you are studying in, what branch?
Actually, I have passed BTech. Uh, 2022 batch from mechanical engineering.
Okay.
Uh, and after that, I have done a diploma course on design based
Hmm.
on SolidWorks and Fusion,
Okay.
AutoCAD 2D.
Yeah. Mm-hmm.
And now I am doing this course.
Okay. Okay. So you are placed, or you are looking for placement or research? What is your?
I am not placed. After this course, I want to look at the possibilities. I am interested in robotics.
Mm-hmm.
Um, Actually, I have started research about this subject
Mm-hmm.
in the third year of BTech.
Mm-hmm.
I was little late for that, starting
No,
with Arduino.
everyone is late only.
Uh,
Everyone is late, so it's not a problem. So you are on the right platform, and you are doing the right thing, doing the assignments and all. Just also strengthen your maths if you want to do research. Okay.
uh,
And if you want to make robots, then also focus on hardware skills. Like robotics is a multidisciplinary area, not just mechanical will not help. Only the CAD design of the robot will not help. You also have to study some uh, Arduino, Raspberry Pi, Okay, make some see some cool projects online and recreate them. Then you will develop the skill also. Okay.
I have done some projects watching YouTube videos like
Uh-huh.
smart dustbin and line following robot,
Yeah, good,
remote
good.
control,
Yeah.
and
Yeah, then it's nice.
so on.
Then you should do the like try to implement the algorithms what you are learning in this course. So that is the next level.
Yes,
Yeah, ROS, you know robot operating system. ROS, have you heard of it? So that is the what is used in robotic industry for programming robots. So you code in Python or C++ for that anyone, but it is like it's little bit hard to learn, but that is the industry standard. So if you have a robot that is complex robot, that is, autonomous and it is sensing and it is, doing path planning, computer vision, so many tasks it is doing at the same time. So at the same time, many codes have to run in parallel, right? Only one code is not there. So in line following, only one code was there. But here, so many tasks are happening in parallel. Like your eyes are seeing, your legs are walking, your hands are picking up. Okay, so many things are happening in parallel, right, in your brain. So a lot of communication and everything is required, and so we don't have to do that. The robot operating system will do that. Like Windows we have, na? So what Windows will do? Windows will allow your music to play, your PowerPoint, your Google Meet, everything to play at the same time. Like that, robot operating system will allow all your codes to run and communicate with each other. Okay, and so that is used in industry, and that is what you will have to learn if you want to have a robotics job today. That is the reality. So if you can
sir,
focus
which program will be best for this?
Python programming language is good to start Python, and robot
Okay.
operating system ROS is you have to install it, and all instructions are given on this ROS wiki. If you search on Google ROS wiki, you'll get, and you need Ubuntu for it. You cannot work in Windows. Okay, so you will
Okay.
need Ubuntu laptop, and once you get into that, you can make this uh, more complex robots, more complex than line following.
Okay, sir.
Anything related to robotics or anything you can ask if you want to know about IITs or anything like that, you can also ask. So I am here for your questions and your for you only. Yeah, so cute baby love has said dynamic simulation. Okay, so what exactly related to dynamic simulation is your problem? Like anything specific? Can you be more specific about your question about dynamic simulation? Are you there? Hello? I'm sorry, I'm coming to your question a bit late. Uh, but what exactly so that I can help you out with that? So is there some error in your code or what? Or you want me to talk about it in general? It's very important that you do the course. Okay, basic differential wheel drive. Okay, okay. So what about that? So you have okay. So let me open the previous slides. Week 3 slides. Yeah. So you had the dynamic equation given in the Professor Santa Kumar's slide, right? So you just write that equation in matrix format, right? And then you do the Euler integration. Na? So if you have something like x double dot is equal to f of x, so sorry, x dot equal to f of x, you write in this format and then you do the Euler integration. That is what, yeah, even I think you can be more specific than this, like basic differential wheel drive. Okay, but what about basic differential wheel drive? You want to know the equation what you have to use? Is that your question? So this was the equation, I think we have discussed, I think so. Yeah, so this was the equation which gave us the relation between the wheel speeds and the force and the moment that is acting on the entire robot. Okay, and once you know that, then you go to the inertial frame, or the, where is that inertial frame equation? Yeah, then you go here, na? No, not here. Yes, then you come to this equation. So this is true for all robots, right? This is true for all robots. Then you substitute here, and then you can simulate. So you can go through the code again. Okay, uses. Okay, uses of the differential drive robot. Okay, so uses of differential drive robot or simulation. So simulation can be used in multiple ways. Like, one is to understand your system only. So you simulate your system and see its capabilities, whether this kind of trajectory is possible or not by the robot. Second is for controlling, design controllers. So before putting a controller, so when I say controller, is the strategy by which the robot will take decision to move in certain direction, right? When, let's say, even there are some disturbances on the robot. Okay, depending on the how much error the robot is. Let's say robot is here and it should have been here. So you know there is some error over here, and then the robot will try to minimize this error, so that error minimizing will happen if you have certain type of control law. Okay, let's say you choose PID, then it will try to like reduce the error. Okay, it will calculate the control input in the direction where the error reduces. So what will happen, uh, but so but you have to test this, and where are you going to test it? In simulation, because if you directly test on the actual hardware, then you can damage the hardware. So that is why you need dynamic simulations. Why kinematic and dynamic? So kinematic simulation is when dynamics very hard, uh, and you need some first order quick simulation result. You can use kinematic this thing. But if you have enough data about your system, your enough parameters, then you can use dynamic simulation, uh, if you have the model of your system. So that will always be more accurate, because it will also consider the forces, the cause of motion, and friction and all those stuff, the acceleration. Okay, but no model is perfect. Okay, there will always be something imperfect, something that we haven't considered. Okay, but we want as much as possible it should be accurate. Okay, and that's why we do dynamic simulation, because we can test all our algorithms in simulation, not on actual robot. Okay, if you only do kinematic simulation, then friction and all those stuff, causes of motion, inertia of the robot, that won't be considered. Okay, you said thanks, sir. So I think you have understood. So if there are no more further questions, then we can stop the session. If there are questions, please write them or you can leave the meeting. Okay, bye. Thank you, Sanjay and cute baby love. Okay, bye bye.